Let me set the scene for you. You need something to eat. Fast. You open up the freezer, and there, thankfully, you find your emergency meals. Pre-portioned, pre-cooked entrees, complete with a vegetable and protein. Many of us do rely on these meals. But how many of you out there actually stop to think about them? How are those carrots such perfect cubes? How are the noodles perfectly cooked? Not too mushy or underdone.
The thing with food is that it's a lot more variable than might meet the eye. I'll give you an example. Like every batch of a very simple ingredient like rice is a little bit different. So if you cooked it a little bit longer, a little bit less long, if you put a little bit too much oil, less oil, it changes the stickiness, the density. It's not obvious for humans, and they often actually are very inconsistent because of that.
Yeah, humans are inconsistent. But you know what's a lot more consistent than us? Robots. Rajat Bhageria runs Chef Robotics, a company making AI-powered robots for the food industry. Robots that can sort and assemble your microwave meal on the factory floor. This kind of advanced robotics is called embodied AI, and Rajat is a pioneer in the field. Just like me, he's a computer scientist turned entrepreneur. The intersection of AI-powered robots and food manufacturing is an area I see so much potential in. I'm actually an investor in Rajat's company, and I'm so excited to share with you what Chef Robotics is about. In this episode, we'll get into the nitty-gritty of how robotic AI works and can solve some of the biggest labor shortage problems we have. We'll also dive into Rajat's own background as an entrepreneur and how he's building a business on the cutting edge to scale. I'm Rana el Kaliouby, and this is Pioneers of AI, a podcast taking you behind the scenes of the AI revolution. Hi, Rajat.
Hey, Rana. Thank you for having me on. I'm excited for this conversation.
So I want to set the stage here because this is our first episode on AI robotics. And not all robots are AI-driven. In fact, most robots don't have any AI in them at all.
Yes.
And a lot of AI today lives in the software world, right?
Yes.
It's like ChatGPT. It doesn't have any physical embodiment. But you live at the intersection of both AI and robotics. And we often refer to that as embodied AI or physical AI. So how would you define that?
Yeah, it's a good question. I mean, I think colloquially the definition that like roboticists use is this idea of like basically you sense the world, you make decisions, and then you actuate. That's basically kind of the robotics kind of framework that most people use. And now there's this fourth idea of like communicate, which is like communicate to a user about, hey, like what's the state of the robot? Like if you go to Waymo, for example, it'll show you like why it stopped or things like that, right? There's quite a lot of progress, as you called out, happening in digital AI or like software AI with LLMs and VLMs and things like that.
A VLM is a visual language model. Instead of being trained on large amounts of data to generate and translate texts, like LLMs do, visual language models are multimodal and are trained on images, videos, and texts.
I think I'm very excited about the intersection of that idea to the physical world, just given that the majority of GDP is in the physical world. And of course, we live in the physical world. So I think perhaps some of the biggest impact will be there.
So Rajat, what does Chef Robotics actually do?
The way you can kind of think about it is we essentially have two things we make. One is kind of this AI-enabled software. We call it Chef OS. It's really the software on how to manipulate food, which is to say, how do you manipulate thousands of different ingredients, no matter how you cut it and cook it, at any portion size, into any tray, any compartment within the tray, things like that. So that's just kind of Chef OS. And of course, to make food, you need hardware. So on the hardware side, we mostly use actually off-the-shelf hardware that we kind of integrate into a product that we kind of scale across our customers. And then we also have a set of utensils that we have across our customers. And then we kind of course, combine the two, and we kind of have this kind of system that we can deploy at customers that will flexibly automate their production and help them basically increase production volume.
Chef Robotics works with companies like Sunbasket, the healthy meal delivery company, and Amy's Kitchen, the organic food pioneer. We're both computer scientists by background, and we actually both spent a lot of time in the computer vision world. And then we also both spent some time in the business and the investing space. I am so curious how all of this culminated into the origin story of Chef Robotics. So I'd love to hear from you, kind of your journey starting Chef, and how did you land on the food industry in particular?
Yeah, it was definitely a roundabout journey, which didn't really make sense at the time, but I think the puzzle pieces kind of connected in hindsight, I guess. When I was kind of getting into like engineering, I was actually planning to be an electrical engineer. I did a bunch of research in high school with electrical engineering because my plan was to be electrical. But then basically the first week of college, there's this hackathon. And I decided to enter with a few friends, and we actually did really well. And I was introduced this idea of computer science and software in a more substantial way, I would say. And it was so exciting because electrical felt slow, relatively speaking. Computer science is very fast and exciting. But also that hackathon led to the creation of my first company, Third Eye. We were using computer vision to recognize what's in front of you for the visually impaired. So that was my real kind of first kind of real kind of experience with AI and computer vision. And I think both those experiences, like of course the coursework, but also more importantly, Third Eye, kind of got me excited about this idea that really software's biggest impact will be on the physical world. At that point, it was like, okay, well, I wanted to do something in this idea of embodied AI, what you alluded to, but I didn't know what product or company to start. But I also had seen the graveyard of robotics companies. Like robotics, honestly, has been tough. Historically, it's been tough. I think it's gaining a lot of excitement in like the 2020s right now. But there's been a lot of robotics companies that didn't work out. So I was like, okay, I believe this idea that AI-enabled robotics is going to be huge, arguably the biggest industry on planet Earth. But I wanted to be very practical. So I also kind of did a bunch of coursework in economics and business. And I started a small VC fund. And I think all of that kind of really allowed me to understand the economics of robotics and how economics of how these older industries work, I would say. So I think it was like kind of the background from, the software, computer science, Third Eye experience, and then kind of economics, business, venture capital. I think those experiences kind of coalesced. And I think I came into this idea of like starting some robotics company with an appreciation that I think it's just as much of an economics problem as it is a technology problem. Because if the ROI doesn't make sense, then our customers are not going to buy these robots. I think the reason the food industry happened is actually quite practical. I want to work on the biggest thing that I possibly could. So I was like, okay, well, the best proxy for that is the number of humans who do that job today from a labor perspective. So I looked at the Bureau for Labor Statistics data, and the biggest job was actually nursing and personal care aides, which I didn't feel was tractable by AI today. The next most common one was retail salespeople, same thought. Food service was actually number 3, food preparation broadly. And then, of course, we immersed ourselves in the food industry. Like we lived literally more or less with our customers until we really understood how they think and what they care about. And that's how we learned about it. But it was a very practical decision, I would say.
And then what did you find was the gap that you kind of went on to solve?
When I had this thought about the food industry, I wasn't trying, I think there's been a lot of robotics companies that kind of put this idea of I want to do robotics on the customer. Like they kind of have leading questions. They're like, where do we put the robots? I think we had the opposite question, which is, hey, look, we're excited broadly speaking about food. What kind of pain points do you face, right? Not kind of setting aside AI and technology and robotics, all of that. But what was interesting is that every single customer, without exception, we talked to, essentially said their biggest pain point was labor shortage and flavors of that, which is that even if they could hire the labor, it's really hard to retain the labor. I would hear stories about how people would turn over 300 to 400% per year. Now, by the way, food is a little bit more intense than other environments, like even worse than perhaps construction and agriculture and warehouses, mainly because it's extremely cold, like 34 degrees Fahrenheit, or extremely hot, either extreme.
This isn't the cooking food problem. This is the packing and food assembly?
Yeah, so we hadn't gotten there yet. We were having these conversations. It was like, broadly speaking, what's your pain point? It was like labor, right?
Right.
And they were like, it's really hard to hire because of the hot room or the cold room. Even if you're doing assembly or packing, it's still hot because you're next to the stove and the grill, right? So I think that was where we were at that point. And then the next step was, like you said, what task? We learned that actually assembly is the task that all of our customers asked us to focus on, not cooking or prepping. And this was also kind of weird to us because, when you cook at home or I cook at home, cooking takes the longest. And number 2 is prepping. And then finally assembly is like seconds, right?
Right.
What I learned is that, at even a little bit of scale, that's not true anymore. The assembly is actually 60 to 70% of the labor force. Basically, our customers told us you should focus there.
I love that you talk about your company as a robot staffing agency. Say more about that.
The big pain point that this labor shortage results in for our customers is that they're running under capacity. And one thing I should just say is that at the moment we're selling to really food manufacturers. We do also want to sell down the line to fast casual restaurants, prisons, hotels, stadiums. Today our customers are food manufacturing customers. So think big food factories. Their biggest pain point is that because they cannot hire these people, they are running way under capacity. What that means essentially is, let's say that they have 10 conveyor lines. They can only staff, let's say 7 or 8 of them at a time to really, make the production numbers they need. So they're basically leaving revenue on the table. And hypothetically, let's just say they can staff all 10. Even if they can staff all 10, they have so much turnover that sometimes it doesn't make sense to staff all 10. Because they're just going to have to train people constantly. So basically, what we can say is, look, we're going to be this kind of staffing agency in the sense that we're going to charge you a recurring fee. We're not going to charge you a big CapEx upfront.
CapEx, as in capital expenses. These are the big upfront costs for upgrades and things like equipment. Typically, these kinds of robots are charged as a capital expense.
A lot of automation is big CapEx purchases. We don't do that.
Right.
You're going to pay us a yearly recurring fee, which is less than the cost of people. So you're paying for us just like you pay your people. And basically, you can run production now. You can go from running 8 lines at a time to now running 10 lines at a time, which is a huge, huge ROI for them.
You're not necessarily replacing human jobs. There is a shortage of labor in this particular application. And you're stepping in with robots to fill in this gap, which I think is a lot of people's fears and concerns around AI is about AI taking jobs.
Yes, I think that's exactly right. And more generally, I would just say that anytime you have automation, automation is not a new idea. AI is a new idea, but automation is not a new idea.
Yeah.
The tractor is automation, right? The dishwasher is automation, and the steam engine, it's all kind of automation in some regards. It's always created a lot more jobs in aggregate than it's taken, right? Because what happens is that the cost of goods goes down, businesses kind of burgeon, and there's the economy kind of swells, and there's a lot more jobs in aggregate created by this than there's taken.
So we've talked about why Chef Robotics came to be and how its services can help food businesses. But what does putting these robots to work actually look like? Set the scene for us. Take us to one of these food manufacturers. What does it look like, and how does the robot come into play?
Yeah, so maybe I can give you a sense of what a status quo is, and then we can talk about how Chef fits in. So status quo is basically of these long, big assembly rooms. You might have 2 conveyor lines, you might have 40 conveyor lines based on the volume that the customer might be doing. On each assembly line, basically you have stations. Each station has a person, and the person has a big tub of food that might be rice, carrots, diced green beans, whatever ingredient it might be. And they're basically scooping ingredients from the source container into individual customer containers as they move down the line. The customer containers might be frozen meals, they might be fresh meals, yogurt parfaits, sandwiches, wraps, burritos, whatever kind of food the customer might be making that day. And so that's kind of status quo, right? And just to be clear, these are high mix customers. What I mean by that is that they're not just line 1 isn't just doing the same meal over and over again. They'll change over the line. So they might do 10,000 trays of Cobb salad, and then they'll change over the line and they'll do a Caesar salad. What we do is we say, okay, look, line 8 over there is not running because of lack of people, or really we'll find opportunities to help. Right. And we make these AI-enabled robot modules, we call them. They're modules in the sense that they are modular. They're the same footprint as a human. You can just slide them onto the line. They're on wheels or casters, so there's no retrofitting required. And essentially, each module takes up the same footprint as a person. The only inputs we need is really compressed air and power, which every facility in the food world really has. At that point, basically what you do is you say, here's the meal I want to run. Let's say I'm running the Caesar salad. Then you might say, here's the ingredient I want to run. Let's say it's the leafy green. And then you select the portion size. At that point, Chef will kind of query the relevant policy, the AI policy, and how to manipulate that leafy green. And of course, every leafy green is a little bit different, but it'll get the relevant one. And it'll ask you to load the pans of food, the pans of leafy green. It'll also ask you to load a relevant utensil. Each policy has a associated utensil, which is kind of similar to a human utensil. So you attach the utensil, and then you press play. That entire process, by the way, takes all of a couple minutes. It's very quick. And at that point, Chef will detect the trays as they move down the line, and then it'll place onto those trays as they move down the line, basically. So we use computer vision to detect where the trays are, and that allows us to kind of adjust for, the tray's rotated, or there's no tray, or there's increasing acceleration in the conveyor, decreasing acceleration, or the conveyor slanted, or the conveyor skewed. There's all these variations you see in the physical world. And we can be robust to all of that using that process.
This point is really important because automation in the food industry has been around forever.
Right.
What is different about you guys' approach is that you're harnessing AI, and we're going to go under the hood in a second to talk about like what exactly are you leveraging in terms of data and models. But for now, you're using AI, and that's giving you flexibility.
Right.
You don't have to have a different robot for lettuce and another one for carrots and another one for ice cream or whatever.
That's right.
So can you talk about that? I think this flexibility and the use of AI is really key to explain.
If you were to get a piece of traditional automation, it's kind of like you can think about it as a bunch of stainless steel, a single actuator, maybe a very simple sensor like a phototransistor. It's a very simple hardware, mostly hardware system. So it's very good at doing the same thing over and over again. So an analogy might be like, you can make a dispenser work for, let's say, diced tomatoes. Great. But now if you cut your tomatoes a little bit differently, it's going to get clogged up, right? And it can place into a single kind of tray. And if you change the kind of tray, it won't work again. It can place into, really, it's kind of fine-tuned and kind of hard-coded for one kind of conveyor. If you change the conveyor, it doesn't work. If the conveyor is a little bit farther away, it doesn't work. It's basically a very custom piece of automation, right? That works fine for a certain subset of customers. Like if I'm Kraft Heinz making ketchup bottles, and I'm going to be making 100 million ketchup bottles, of course, I get a dedicated custom line that just runs ketchup bottles all day long, and I get a custom machine just for that, and it works great. For our customers, they have 300 different SKUs, 500 different SKUs. In other words, products, right? You have all these different kinds of meals that you and I might want. And because of that, they don't have custom lines for each of those products. They have flexible lines that change over. So flexibility is key. Traditional automation is not very flexible. So I think the point you made is exactly right. You could solve the high mix problem by having custom machines, essentially, for each ingredient, each portion size, each tray, each placement within the tray, each conveyor. It just goes on and on. So there's all these permutations. Our vision and what we're kind of telling the customers, like, look, and what we've productionized is a single piece of hardware.
Basically an arm with like some utensils at the end.
Yeah, exactly. And what's nice about that is like you can basically pick really any ingredient at any portion size into any container, into any placement within the container, into any conveyor using purely software and different utensil inserts. So it just makes it a lot more scalable and flexible because of that.
Yeah, amazing. So you gave us the example of the large-scale kind of food manufacturer. What are other kind of areas where you're applying Chef Robotics?
Right now, our bread and butter is really these kind of high-mix customers. And I think like the areas that we're excited about within that is really like focusing on frozen, on fresh meals, airline catering, school meals, hospital meals, things like that. Where we want to expand from there is kind of two ideas. Idea number one is horizontally to other sectors in the food industry, and idea number two is vertically. So let me talk about horizontal first. Horizontal would basically be, right now we're kind of working with these high volume customers, right? They're doing, let's say, 10,000 meals a day. And so robots are really good in those kind of environments. Where we'd like to go to next is lower and lower volume environments. Imagine like a fast casual restaurant, like let's say Kava or Sweet Green or Chipotle. If you think about it, they basically have a lunch rush and a dinner rush, and that's like 4 hours, right? So to generate an ROI, right, you basically have to generate that ROI in 4 hours, which is very tough. So your robot has to be very generalized. And not only does it have to generate an ROI in 4 hours, within those 4 hours, it's got to do 90 to 100 ingredients. Like if a robot just does leafy greens for Sweet Green, that's not useful. It's got to do everything. So essentially the thinking for Chef is that food manufacturing is high volume. We're running the robot 16 hours a day, right? So there's a very compelling ROI. And each robot at any given moment is doing a single ingredient. Now, throughout the day, it might do 5 to 6 ingredients, but it's a set of ingredients. And so our thinking is that by shipping robots here, we're collecting a lot of valuable training data on how to manipulate food. And over time, we can use that training data to make a more generalized food manipulation model, which then allows us to go to lower and lower volume environments. Well, the ultimate goal is really being able to do things like fast casuals, ghost kitchens, things like that. So that's kind of how we think about scaling horizontally.
Yeah. So imagine robots behind the counter preparing your lunch at Chipotle and Sweet Green. That's a goal for Chef Robotics. But Rajat doesn't just want to grow into different markets. He sees a lot of potential value in all of the data they're collecting about food production. So that's the horizontal kind of vision.
Yeah.
What about the vertical integration or the vertical roadmap?
Yeah, the vertical idea is also interesting, which is that right now what we found in the food industry is there's actually relatively little software and data that these companies are capturing. Some of them have more than others, but it's quite a bit more manual than you might think. So I'll give an example. From a QA perspective, they'll randomly sample meals at the end of the line. And it's like they'll do it like, X times per hour, which is cool. It's useful. But we are measuring the weight of every single meal, first of all. And we're doing that on the ingredient level, not the full meal level, but every single ingredient we're measuring. Okay, we're doing the same thing for placement. Like, okay, we're measuring every single metric of how the placement aesthetics look. We have a lot of metrics around throughput and basically food wastage. And there's all this data we're collecting. And I think over time, what we'd like to be able to do is leverage that data and help build tools for line monitoring, placement QA, pick weight QA. Because at the center of food is really these metrics around quality, right? Quality, throughput, things like that. So I think there's a lot of opportunity where we can basically over time become more of the operating system of how these companies work from a software perspective. And you can imagine also a software about like scheduling and line planning, right? Optimized for robots, optimized for robots and humans, for example.
Yeah. I think that's really cool because QA or quality assurance today, as you say, isn't happening with every single meal being served, but you can do just-in-time QA, right? Because you've got all the data anyway.
Yes.
So that's really awesome. And you can interject, if I don't know, I'm going to make this example up. You tell me if it makes any sense. But say we're putting, some rice on and then some avocado, and then we're going to put like chicken, whatever. And if it messes it up in the avocado step, you don't have to wait until you've put the chicken and all the other stuff. You can intervene just in time and say, okay, this one doesn't work. Take it off the line.
Yes,
Does that make sense?
That totally makes sense. And actually, we do more or less exactly that. And further, you can even, like the thing with food is that it's a lot more variable than might meet the eye. I'll give you an example. Like every batch of a very simple ingredient like rice is a little bit different. So if you cooked it a little bit longer, a little bit less long, if you put a little bit too much oil, less oil, it changes the stickiness, the density. It's not obvious for humans, and they often actually are very inconsistent because of that. So I think one thing we have found is that we can actually, because we're measuring in real time, we can adjust on the fly, right? If we find that today the rice was overcooked, undercooked, too oily, less oily, whatever it might be, whatever dimension it might be, we can adjust to that, which allows for much better consistency, which ultimately allows for way less food wastage, which ultimately actually allows for much better ROI to our customers. You can also imagine an aggregate. I mean, if you have thousands and tens of thousands of robots, in aggregate, that can actually have a pretty big impact on food wastage globally too.
But there are so many variables in the food industry that go beyond cook time and amount of oil. For example, produce isn't consistent. A cup of blueberries and a handful of kale need to be picked up differently. You don't want to squish the blueberries, and you can't exactly scoop kale. So how does Chef Robotics robots navigate this problem? What is the robotic arm seeing? What's the sensor? What is its senses? Start there.
Great question. So we use two RGBD cameras.
This is a kind of camera that can help make 3D images.
One is kind of pointing at the ingredient pans, and one is pointing at the conveyor pans. Conveyor basically above, overhead.
Okay.
So we kind of mesh those together into a full point cloud, and now we have a good sense of the scene we're seeing. So so that's kind of the main inputs. We also have a scale, literally a weigh scale, underneath the hotel pans themselves.
Okay.
You got to pick and you got to place. So from a picking perspective, the job is like, okay, how do I figure out where to pick from? Remember, there's like hills and valleys. There's like mounds, basically.
A whole bunch of blueberries, yeah.
Yes, exactly. And they're not like a flat, uniform surface. So first of all, where do you pick? But also, how do you pick to make sure you don't crush the blueberries, to not have spillage? So that's kind of what's encoded in the pick parameters of this policy. We do have different utensils, and these utensils are actually quite... They're pretty cool, actually. We have some really great mechanical designers that like can pick it without actually damaging the material, which is pretty cool. And on the placing side, same idea, right? So now you have to detect and track the containers. It's very similar technology to like detection and tracking in a self-driving car, and then place into the relevant compartment or quadrant of a tray. And even there's similar parameters. So one parameter that's like that we have is like this idea of dwell time, which is this very simple idea. It's this idea that if you have a very sticky material, imagine like peanut butter. It takes peanut butter some time to physically fall down. So you have to basically track the container for a little bit longer to make sure the peanut butter fully makes it to the container. So there's all these parameters basically we have that allow us to successfully pick and place an ingredient while maximizing for all these different dimensions I talked about.
What's something that the robot is not ready to do yet, but you're actively working on?
One that's been tough is we call it big bulky items.
Okay.
Think about like a very big broccoli floret, right? Let's say it's like broccoli floret like this big, and you have like you want to pick up like a bunch of them, right?
Yeah.
Well, let's say the target's like you want to pick up like 150 grams of broccoli for whatever reason. Maybe it's like a party tray or something. If you just pick up, you're probably going to get one piece too much or one piece too little. And what a human does is looks at that and they say, let me remove the big piece and let me put a small piece in. And so the robot, once it picks up, it knows that it got too much or too little. But then how do you edit? Right. So we're trying to build in functionality to like edit and figure out how we can kind of do these big bulky. Because the thing is, if you get one piece too much broccoli, then you're super high. If you go to one piece too little, then you're super low. And you, of course, can't just slow down throughput because the line's going to get slowed down. So that's a more complex problem that we're working on right now.
So cool. What's something that you're not even trying to have the robot do? What's a task that's just out of the realm of the robot right now?
We find a lot of like, weird ingredients that you might not think about. So like lasagna sheets, right? There's like, literally like, it's like big trays and people are just taking sheets of lasagna to make that. It's quite complex, right? And they're kind of stacked up one on top of each other, sticking to each other. That is quite tough, right?
Okay, no lasagna. Okay, no lasagna for you guys.
Not right now. We see a lot of noodles, like long, stringy noodles. That's actually quite tough as well at the moment. We can pick noodles.
Yeah, it's probably slips, right?
Yes.
Oh, you can?
Well, this is what I mean. It's like it's such a hard optimization. Like you look at Chef and it seems simple in some regards on the surface. Oh yeah, you're picking and placing ingredients. But the thing is that like you can pick noodles, but can you pick very consistently? Do you spill?
Right.
I mean, when you place, do you get like some of the strings on top of the tray? Now it's ugly. It doesn't look aesthetically nice. So there's all these dimensions you have to kind of optimize for, which is where the tough part is. So we can pick, but we're not very consistent. So now there's work that we are thinking about to like optimize consistency and get it to a production ready state, basically.
So I spent my entire career thinking about human-machine interfaces and what that could look like in the future. And I'm especially interested in this idea of a cobot, a collaborative robot that's meant to work alongside and interact with humans. So for Chef Robotics, have you thought about like how these robots are going to coexist and work alongside other humans on the factory floor?
Yeah, absolutely. And actually, I think it's a really important question that I would say that a lot of folks don't think about. Broad strokes, why is this important? Well, I think there's a lot of robotics companies that historically have built really cool technologies.
Right.
But I think the usability and the human-machine interaction is really what takes a technology into a product and then ultimately, I think, a solution. I'll give you a good example why this matters for us and why we spend so much time thinking about it. Oftentimes our users, not the customers, not the people writing the checks, but the people who are using the robots on a day-to-day basis, they're oftentimes non-technical, right? Most of the time. Because of that, it's really forced us, honestly, to like make an extraordinarily simple system that's also like feels nice to use. So now, for example, like, you can see like a 3D view of exactly what the robot sees, right? Like what trays are going down the line. Sometimes the tray might be too far and the robot might not attempt to place it. And then you understand, oh, okay, that's why. The tray was too fast, too far away. Yeah. And how do we really optimize the robot to be helping them do their job in a very simple way as opposed to detracting or making it hard for them?
I want to flip it on its head a bit. Do you think there are any skills that we as humans need to learn as more and more robots will become the norm, right? We'll be surrounded by robots doing all sorts of stuff. So do you think we need to not evolve, but like what kind of skill sets do you think we should learn?
It's a great question. I think there's this idea that like faster is always better. Let's just go fast as we can. But oftentimes like what that leads to is like you kind of accelerate and then, your line is down because your people can't catch up or your machines can't keep up. And then you accelerate again and you slow down. So, and then at the end of it, your like average production is actually much lower. Whereas like steady production is actually much more, it's better for people. It's like line balancing, right? And load balancing is a lot better. And again, that's specific to manufacturing. It's a more general concept that I think applies, which is this idea of like, if you try to optimize a process, if you don't alleviate the bottleneck, you won't actually solve anything. Like, let's talk about the Chipotle line. The Chipotle line, the constraint, if you think about it, is oftentimes the assembly. It's not oftentimes the cooking or prepping. So if you automate the cooking or prepping using robots or really any process, great, that might be useful, but you actually probably didn't solve anything because you didn't alleviate the bottleneck. So it's really important in really any process to alleviate the bottleneck. And you shouldn't automate a process before you've optimized and you've simplified and potentially even removed the process. I think it's a manufacturing concept, but it generally applies to really day-to-day life.
Earlier this year, you raised a fresh round of funding. Congratulations.
Thank you.
Can you share a little bit, how are you planning to use this capital and what are some of the next exciting milestones for Chef?
A lot of the funding is really going towards making our product even better. The reason I say this, by the way, is that the approach we've taken is very much kind of finding these fairly large customers, and really trying to make them very happy so that we can scale within them. So it's more of a land and expand business model, as opposed to let's get dozens and hundreds of different customers that we have to make happy. Most of our customers have multiple plants. Each plant has opportunity for dozens of robots. So, but they're of course only going to do that if the product really works. So a lot of the financing is going towards making even better models to do more ingredients, be more consistent, spill even less, have faster throughput. Basically, there's these 6 or 7 metrics that matter for a chef. It's not too hard to think about, right? If you think about manufacturers, they care about throughput, they care about quality, they care about waste. I mean, there's these few metrics we have to optimize for, and we really maniacally optimize for them, while also maximizing for flexibility. Because like you said at the very beginning, you can't have a machine that just does only that thing. It's got to do all these things, but also be very flexible. So a lot of the capital is really going towards building out the engine AI team to continue making the products even flexible.
Well, thank you so much for this conversation. Fascinating work and very exciting.
Yeah, thank you, Rana. This was awesome. Thank you for having me on.
Rajat, like me, is a techno-optimist. His work adds a lot of nuance to the conversation around AI and jobs. Like Rajat, I truly believe that AI will not only create future jobs, but also solve for the labor shortage crisis in some industries, like manufacturing. But there is so much potential for embodied AI beyond the factory floor. We're so excited to share with you conversations about AI-powered robots in other industries and even in your home. We want to hear from you. What's an area of work that you would outsource to AI? Leave us a voicemail at 601-633-2424. We love hearing from you, so keep calling in.